Self-practice 4.13, questions number 1. Solve the following equations by giving answers in 3 decimal places. A. 4 to the power of 2x minus 1 equal to 7 to the power of x. So both sides here are written in index form. If you are able to change the base on both sides to the same base, then you can just compare the power. But here 4 and 7, you just weren't able to do so. So here we're going to use the help of logarithms. So always refer to the law here to help you to solve for these questions. So first, I'm going to log both sides with log base 10. Here, the value on the left-hand side and the value on the right-hand side will still remain the same. So next, using the power law, I'm going to move the power to the front. So here I'm going to have brackets 2x minus 1 log base 10 of 4 equal to x times log base 10 of 7. Next, I'm going to expand this. So here you're going to get 2x times log base 10 of 4 minus log base 10 of 4 equal to x times log base 10 of 7. Here we want to solve for the x. So I'm going to collect the x on the left hand side. Therefore, you're going to get 2x times log base 10 of 4 minus x times log base 10 of 7 equal to, then I'm going to move this negative log base 10 of 4 to the right hand side. Here we have x on both terms, therefore we can factorize this. So x bracket, so here we're going to have 2 times log base 10 of 4 minus log base 10 of 7. To find the x, it will be log base 10 of 4 divided by 2 times log base 10 of 4 minus log base 10 of 7. So this part here, you just solve it using your calculator. So the final answer for the x will be 1.677. Questions B. 5 to the power of 2x minus 1 equal to 79 to the power of x minus 1. So the base 5 and 79, you weren't able to change it to the same base as well. Therefore, we cannot compare the power. So here we're going to use the same method as questions A. So first, we're going to log both sides with log base 10. So next, using the power law, move the power to the front. So here, brackets 2x minus 1 times log base 10 of 5 equal to x minus 1 times log base 10 of 79. So next, expand. On the left hand side, you're going to get 2x times log base 10 of 5 minus log base 10 of 5 equal to x times log base 10 of 79 minus log base 10 of 79. We want to solve for the x, therefore we're going to collect the x on the left hand side. So here we're going to minus x times log base 10 of 79 equal to, and we're going to move this negative log base 10 of 5 to the right hand side. Therefore, we're going to get positive log base 10 of 5 minus log base 10 of 79. So here we can factorize for the x. So x bracket 2 times log base 10 of 5 minus log base 10 of 79. To find the x, it will be log base 10 of 5 minus log base 10 of 79 divided by 2 times log base 10 of 5 minus log base 10 of 79. So this part, just solve it using your calculator and you'll find the answer for the x is 2.399. Question C, 7 to the power of 3x minus 1 equal to 50 to the power of x. So 7 and 50, you weren't able to convert it to the same as well. Therefore, you cannot compare the power. So here we're going to use the logs to help us. So first, log both sides with log base 10. Next, using the power law, move the power to the front. So here we're going to have bracket 3x minus 1 log base 10 of 7 equal to x times log base 10 of 50. So next we're going to expand this. You're going to get 3x times log base 10 of 7 minus log base 10 of 7 equal to x times log base 10 of 50. We want to solve for the x, then move all the x to the left hand side. So here will be minus x times log base 10 of 50 equal to the positive log base 10 of 7. So the x here on both terms, so we can factorize it. So x bracket 3 times log base 10 of 7 minus log base 10 of 50 equal to log base 10 of 7. To solve for the x, it will be log base 10 of 7 divided by 3 times log base 10 of 7 minus log base 10 of 50. So solve this using a calculator and you'll find the answer is equal to 1.010. Questions number 2. Solve the following equations by using natural logarithms. Give the answer in 3 decimal places. Natural logarithms is the log with base e, or you can write it as ln. Questions A. ln of 5x plus 2 equal to 15. This ln I can write it as log base e. So this will be log base e of 5x plus 2 equal to 15. So we can change these logarithm forms into the index form by using the law that I highlight here. So it will be e to the power of 15 equal to 5x plus 2. To find the x, we're going to move this plus 2 to the left hand side. Therefore, x is equal to e to the power of 15 minus 2 divided by 5. So solve this using a calculator and you're going to get the answer of 653,803.075. Questions B. 30e to the power of 2x plus 3 equal to 145. So on the left hand side, this means 30 times e to the power of 2x plus 3. So first I can move this 30 to the right hand side. It will be 145 divided by 30. So simplify this, you are going to get 29 over 6. So this is written in index form. So I can change it to log form. Refer to this law again. So this will be log base e of 29 over 6 equal to 2x plus 3. This log base e, we can write it as ln. So to find the x, move this plus 3 to the left hand side. Therefore, x is equal to ln 29 over 6 minus 3 divided by 2. So solve this using a calculator. The answer will be negative 0.712. Question C. 5e to the power of 3x minus 4 equal to 35. So on the left hand side, this is 5 times e to the power of 3x minus 4. So I can move the 5 to the right hand side. It will be 35 divided by 5, which is equal to 7. So I can change these index forms into the logarithm form. Refer to the law that I highlight here. So this will be log base e of 7 equal to 3x minus 4. This log base e, we can write it as ln. Then I'm going to move this negative 4 to the left hand side. It will be plus 4. To find the x, it will be ln 7 plus 4 divided by 3. So solve this using your calculator and you're going to find the answer is equal to 1.982. Questions D. ln of 3x minus 2 is equal to 4. So first I can change the ln to log base e. Next, I can change this logarithm form into index form. Then this will be e to the power of 4 equal to 3x minus 2. Next, I'm going to move this negative 2 to the left hand side. Therefore, x is equal to e to the power of 4 plus 2 divided by 3. Solve this using your calculator and the answer is 18.866. Questions E. 41 minus e to the power of 2x equal to 5. So first, I'm going to move this negative e to the power of 2x to the right hand side and 5 to the left hand side. So 41 minus 5 is equal to 36. So we can change these index forms into the logarithm forms in order for us to find the value of x. Refer to the law that I highlight here. So this will be log base e of 36 equal to 2x. And this log base e we can write it as ln 36. To find the x, this will be ln 36 divided by 2. So solve this using a calculator and the answer will be 1.792. Questions F. ln of bracket x plus 1 square equal to 4. So first I can write the ln as log base e. Next, to find the x, we're going to convert this log form into index forms. Therefore, this will be e to the power of 4 equal to bracket x plus 1 square. To find the x, first we're going to move this square to the left hand side. It will be plus minus square root e to the power of 4. Therefore, x is equal to plus minus square root e to the power of 4 minus 1. So we're going to have two answers. One of it is positive e to the power of 4 minus 1, or the other one will be negative square root e to the power of 4 minus 1. So the first one here will give you the answer of 6.389, and the other answer will be negative 8.389. Questions number 3. The price of a house after n years is given by Rm 260,000 times 9 over 8 to the power of n. Determine the minimum number of years for the price of the house to exceed 300,000 for the first times. So we're going to use this formula to find the price of the house after n years. So we want to find the minimum number of years of the price house to exceed 300,000. The word exceed is mean more than 300,000. Therefore, I can write it as the price of the house, which is 260,000 times 9 over 8 to the power of n. So the price of the house here must exceed 300,000. So here is mean multiplications. So first I can move this 260,000 to the right hand side. So it will be 300,000 divided by 260,000. So here, after you simplify it, you will find that it is equal to 15/13. Now, on both sides here, I cannot change it to the same base to compare the power. Therefore, to solve for the n's, which is the number of years, I'm going to log both sides with log base 10. So next, using the power law, I'm going to move the power of n to the front. So it will be n times log base 10 of 9/8 greater than log base 10 of 15 divided by 13. So to find the n, I'm going to move the log base 10 of 9/8 to the right hand side. So solve this using your calculator, you will find that the n is greater than 1.2. So the number of years is a whole number. So when n is greater than 1.2, the nearest whole number will be number 2. Therefore, the minimum numbers of years will be equal to 2. Questions number 4. A company saving after n years is Rm 2000 times 1 plus 0.07 to the power of n. Determine the minimum number of years for the saving to exceed Rm 4000. So this formula is for you to find the saving after n years, we want to know the number of years when it's going to exceed 4000. Exceed is mean more than. Therefore, the number of saving after n years, which is 2000 times bracket 1 plus 0.07 to the power of n greater than 4000. So here is mean multiplications. So I can move this 2000 to the right hand side. And 1 plus 0.07, here I can write as 1.07 to the power of n greater than 4000 divided by 2000. So 1.7 to the power of n here is greater than 2. So I cannot change the base on both sides to become the same base so that I can compare the power. Therefore, to continue, we're going to solve this using the log. So on both sides, I'm going to log it using log base 10. Now, using the power law, I'm going to write the n's to the front. So it will be n times log base 10 of 1.07 greater than log base 10 of 2. To find the n, it will be log base 10 of 2 divided by log base 10 of 1.07. So solve this using your calculator, you will find that n is greater than 10.245. So the n here is referred to the number of years, which is a whole number. So the whole number nearest to greater than 10.245 is 11. Therefore, the minimum number of years, which is the n, is equal to 11. Questions number 5. After n years, Mr. Chong's money in the bank is Rm 4000 times 1.1 to the power of n. Calculate the number of years for Mr. Chong's money to exceed Rm 5100 for the first time. So this formula is for you to find the Mr. Chong's money in the bank after n years. So 4000 times 1.1 to the power of n, which refer to the Mr. Chong money. Here we want to know when it's going to exceed 5000, which is 5100, which means more than. So we want to solve this and find the n. So first, I'm going to move this 4,000 to the right hand side. So it will be 1.1 to the power of n greater than 5,100 divided by 4,000. Solve this, you will get that 1.1n is greater than 1.275. So both sides we cannot change it to the same base to compare the power. Therefore, we're going to solve this using the log. So we're going to log both sides with log base 10. So next, using the power law, move the n's to the front. So next, to find the n, we're going to move the log base 10 of 1.1 to the right hand side. So solve this part using the calculator, you'll find that n is greater than 2.549. So the n is referred to the number of years, which is a whole number. So the nearest one, when the n is greater than 2.549, is n equal to 3. So the number of years is equal to 3 years. Questions number 6. The air pressure in Hg at a height of 10 km above sea level is given by P equal to 760 e to the power of negative 0.125 h, where h is the height in kilometer and e is equal to 2.718. Determine the height above sea level if the pressure at that height is 380 mm Hg. So we can find the pressure using this formula. So 760 e to the power of negative 0.125 h. So when you substitute the height above the sea level to the h here, so the pressure will equal to 380. So here is mean multiplication. So first I'm going to move the 760 to the right hand side. So it will be 380 divided by 760, which is going to give you the answer of 0.5. So here is written in index forms, so we can change it to log forms. So here I can write it as log base e of 0.5 equal to negative 0.125 h. So log base e, we can write it as ln 0.5. Now to find the h, we're going to move this negative 0.125 to the left hand side. Therefore, h is equal to ln 0.5 divided by negative 0.125. So solve this using your calculator and you will find that the height is equal to 5.545 kilometer.